Hey guys, ChrisFix here, and today I need to replace the brakes on my truck. But instead of showing you how to replace brakes, because I've done that multiple times with in-depth how-to videos, how to replace front brakes, rear brakes, drum brakes, and on different makes and models. So instead of doing another how-to video on how to replace brake pads, we're gonna be doing something way cool. Today, I'm gonna show you how brake pads are made. That's right, we're gonna go to the factory and we're literally going to make brake pads for my truck. It's one thing to go to a store and buy brake pads and install them. That's awesome. But it's a completely different thing to learn how these are made, the process that goes into it, the testing, and the different types of brake pads. So the issue I'm having, you can see there's plenty of meat left on these brake pads. There's about half the life left on here. But the problem I'm having is you see all this rust in here and all this rust in here. Because the brake pads slide back and forth in the brake caliper, this part where it's painted, well, the paint gets rubbed away and shows bare metal, and that bare metal will rust, and this right now is getting seized into this brake caliper and the brake isn't budging. So although we have plenty of life left on our pads, we still have to replace them because they're getting rusted. So let's head out to the brake pad factory and let me show you how brake pads are made. So while many brake pads today are made in China or India, I'm grabbing a flight from Newark, New Jersey and heading to Toronto, Canada. And here in Toronto, we're visiting NewCap, the makers of NRS brakes, and their brake technology is used in OEM brake pads for big car companies like GM, Ford, Chrysler, Audi, and even Bugatti, and aftermarket companies like Brembo. So this is the real deal. We're about to see from start to finish how brake pads are made. It all starts right here in their engineering department. In the United States alone, there are over 3,000 brake pad designs like this one. This is actually the one that fits in the caliper of my truck, which is this right here. Each brake pad has to be manufactured to strict tolerances because when you install brake pads in your car, they have to fit nice and tight, but still have room to move in the caliper so it doesn't get stuck. And to make sure each brake pad fits correctly, it all starts right here on the computer. This is the 3D model of my truck's brake caliper, and since we're making brake pads for the truck, all the precise measurements are going to be taken from this model and are going to be used to create the die, which is going to stamp the brake pad backing plate so it'll fit properly. So let's go and check out the stamping process. So we need to head over to the stamping facility for step 2, where we're going to take raw steel and stamp the brake backing plate. And there is no shortage of steel in this factory. Each one of these coils weighs between 3 and 5 tons, and there are stacks of them to the ceiling. Look at all this steel. And this steel is super important because it's going to be turned into the backing plate, which is the foundation of the brake pad. So high quality pickled and oiled steel is all this factory uses to make their brake pads. Let me show you why. So all of these steel coils that you see in front of us are hot rolled. It means they're formed by heating them up and then rolling them out into shape. After the steel is hot rolled, there are 2 things that could be done. First, they could leave the steel as is, and a scale, a rust forms on top. That's called black steel. This steel isn't treated, so that black that you see on here is all scale and impurities. The positives of this are it's less expensive to produce than pickled and oiled steel. But the negatives are you have those impurities, you have this scale, you have this rust on here, and we didn't even make these into brake pads yet. And on the other hand, we have pickled and oiled steel. The process of pickling steel is right after it's hot rolled, it's cleaned off with an acid so that you don't get that scale that you see with the black steel. And then oiling it, you can see there's a sheen on here. All they do is add oil so that it prevents it from rusting in the future. Now the negatives with pickled and oiled steel is it costs more than black steel. But the positives are you're starting off with a cleaner, rust and scale free metal. Also, this is what the OEM requires brake pads be made of. So if you're making an OE brake pad, you need to use pickled and oiled steel because it's a higher quality steel. Now I'll show you the difference between pickled and oiled and black steel in the corrosion chamber a little bit later in the video. But for now, know that this manufacturer only uses pickled and oiled steel. Now that you know the significance of using pickled and oiled steel, let's get our 4-ton steel coil and bring it to the press. At the back of the press, the forklift operator has to put the coil into the loading bracket, then another worker releases that steel which rolls into the feeder, and now the worker could feed the steel into the press. But since the steel was coiled up, it's curved and bent steel can't be stamped. So first the steel has to travel through a series of rollers to be flattened out so the brake pad backing plate could be stamped properly. Here's a closer look at what's happening. The steel moves along the rollers, which are positioned to make that steel flat. Then that flat steel comes out and gets fed directly into the press, which has one last set of rollers to ensure it's completely flat. Once that flattened steel makes it into the press applies up to 800 tons of pressure to stamp out a single backing plate. 800 tons is like having the weight of 400 passenger cars stacked on top of each other, pressing down on that single piece of steel. That's a lot of pressure. So after the brake pad backing plate gets stamped, it slides down into one of two buckets, and not into the main orange bin. This 2-bucket design is so smart, and here's why they do it. Once one of the buckets gets full, the worker closes the gate to that bucket, and then the other bucket starts filling up. He proceeds by grabbing a backing plate and blowing it off with some compressed air so he could visually inspect it. He's trained to look for anything that indicates the backing plate isn't being pressed correctly. If he sees an issue, he could shut the press, and instead of contaminating the entire orange bin of backing plates, where there could be thousands of them already made, he knows only the top 2 buckets have potentially bad backing plates. So this simple inspection prevents damaged backing plates from getting mixed in with the entire batch, which is very smart. Alright, so check this out. We went from a coil of steel to this, a freshly stamped backing plate. So at this point, the backing plate is the correct shape and has all the holes and studs it needs, but what happens to the rest of the steel that isn't used in the backing plate? On the side of the press, all the extra steel that isn't part of the backing plate is also captured and recycled. What you see here is scrap metal that comes from the area around the backing plate. And this over here is the scrap metal from cutting all the holes in the backing plate. Nothing goes to waste here. That's good for both money savings and for being environmentally friendly. All this metal will be melted down and reused. Alright, and as you can see, this container's almost filled. As this finishes up, now we can move on to the next step, so let's grab a backing plate and bring it to the quality control lab where the backing plate undergoes a full analysis to make sure each one has no flaws and will properly fit the caliper. So here's one of our backing plates, and I'm gonna hand it over to the lab technician who's gonna place it on this high-tech scanner. The dimensional analysis scanner uses lights and cameras to precisely measure every part of the backing plate. It compares these measurements to OEM specifications, in this case for my Mazda B3000 pickup truck. If it isn't within the acceptable tolerances, that'll come up on the screen as red, and if it's good, it'll be green, just like that. Perfect. Alright, and that is a pass. Now every single brake pad backing plate has a serial number stamped into it for complete traceability. This could be tracked back to the original pickled and oiled steel that it came from. So now we know all of our backing plates are stamped to the correct specifications, and since this container is full, we could take it to the next step at the mechanical attachment facility. And just so you get an idea of the size of this facility, let's go for a quick ride on the forklift. This company has a total of 700,000 square feet of floor space, and all of those orange bins that you see that are stacked up, those are all filled to the top with backing plates for almost every car produced in the world. And here we are making brake pads specifically for my truck. How crazy is that? So now the forklift driver is bringing the backing plates to the next step, which is adding the mechanical attachment to the backing plate. So we have the backing plates that we just stamped, and these are going into the NRS machine. This machine is also a press, but it works a bit different than what we just saw. So the worker places a bunch of backing plates into the hopper, which feeds the press. To get you guys the best view, they stopped the press for me, and I literally went inside the press to set up cameras so you could see what happens to the backing plate. Check this out. The blank backing plate is fed into the press, and then the press pushes down to scrape the surface of the backing plate to create hundreds of sharp rasps that point outward. Here's an up-close look at what these rasps look like. These are an important technology that allows the brake pad material to stick to the backing plate without using glue. Now after the brake pads get that mechanical attachment scraped into them, they get transported via conveyor belt and get collected into another orange bin. So we go from this smooth backing plate to a backing plate with hundreds of rasps on the other side that are going to hold that brake pad material on. So with that, we are done with our third step. And now the forklift operator could take the bin filled with the backing plates and bring it to the loading dock, because the next thing we need to do is galvanize these backing plates. And to do that, we have to bring them to a separate but nearby factory. So after a short trip, we're at the galvanizing factory where our backing plates are hung on these racks so they can be coated with zinc. This process is going to put a sacrificial layer to prevent the backing plate from rusting, so let's see how it's done. There are 7 main steps for galvanizing backing plates. First, the rack of backing plates is dipped into a heated water and sodium hydroxide bath, which removes grease from the surface of the backing plates. Next, it comes out of that bath and gets dunked into plain water to rinse off the backing plates. Then it goes into a pickling bath where acids clean any surface rust and scale off the backing plates. Then the rack gets submerged into water again to ensure the acid is rinsed off. And now the backing plates are placed in an aqueous solution and an electrical current is run through them so the zinc ions attach to the backing plates. Now the zinc is bonded to the surface of the backing plate in a thin, even layer to provide rust resistance. Then the rack goes into a post-treatment sealer which improves corrosion resistance. And finally, the last step is to do one last rinse in plain water and pull it out to let it dry. After it dries, all the backing plates are officially zinc coated and therefore rust resistant and ready for the next step. So let's head back to the brake pad factory. And back at the brake pad factory, our freshly zinc coated backing plates are about to look like a brake pad because the next thing we're gonna do is add the brake pad material. Now there are three main ways to add friction material to a backing plate. And the first method, which this factory doesn't do but I wanted to cover, is gluing the friction material. This is actually really common for brake pad manufacturers to do. They get a bare piece of metal because you can't have galvanization because the glue won't stick to it. You also don't have that mechanical attachment. You have a nice flat bare piece of metal and they use heat and pressure to glue the friction material onto the pad. Now since it's not galvanized, it can't be protected by rust, so what they do is they paint it. So you get a painted pad like this. Now this is what my truck was using and this is common on many aftermarket pads. Now the second method is molding the friction material. This factory does do that, and what they do is they get a mold, they put the backing plate in there, they pour the friction material in, and then they use heat and pressure to cure that friction material against the rasps, against the backing plate, so that mechanical attachment holds it in. And then for the third method, this is called the fusion process. It's the newest technology in the brake pad industry, and we're about to get a sneak peek, so let's go check it out. What you're looking at is the fusion machine, and here's how it works. First, the worker places the friction material into the holder, followed by the backing plate with the mechanical attachment facing down into the friction material. Next, the fusion machine rotates and brings the backing plate and friction material to the press. The press pushes down with 1200 psi of pressure to join the friction material and backing plate as one solid piece. There's no heat used here. Instead, the sharp mechanical attachment on the backing plate is pushed into the friction material and then it slightly bends, hooking into the friction so it can't come off. Finally, the machine spins again and a vacuum picks up the brake pads and places it on a conveyor belt to be brought to a worker who will package the brake pads. This is a much cleaner and more efficient method than gluing the friction material or even molding the friction material. And there we go, our friction material is on our backing plate, but there's one more step we need to do. And that is make the brake pad shim, which starts out as this rubber-coated coil of steel, which is straightened out and makes its way to the press. The press then stamps out the brake pad shim, and these shims are used to isolate the brake pad from the caliper to keep the vibrations and noise down. So let me show you one of these up close. All it is a thin rubber-coated piece of metal that goes on the backing plate, and that's all you need to make the brakes a little bit quieter. Now while it's simple, it's important, so let's get it on the back of our brake pad, and all you have to do is snap it on. Good. Now we've officially made our own brake pads from start to finish. So let's package them up, getting all 4 brake pads in here, as well as the stainless steel brake hardware and the piston cushions. And now let's fold the box up and close it. But we aren't done yet. The last step in the brake manufacturing process is done here at their research and development and testing facility, where they have a brake dynamometer, they have a shear test machine, they have a saltwater corrosion chamber. So what we're gonna be doing is we're gonna be testing the brake pads that we made, and as a little comparison, we have some painted brake pads just to see the difference. So let's go get these on the dyno. This is the brake pad dyno, so I'm gonna hand over the brake pads that we just made to the lab technician, and he's gonna install them in the caliper. Then the doors are closed for safety because we're about to torture test these brake pads to make sure they could hold up to the harshest conditions. So with a hit of a button, the dyno starts up and spins the brake rotor to highway speeds. And then we're gonna do multiple panic stops, like if there was an accident in front of you and you had to slam on your brakes to come to a complete stop. The only difference is we're gonna do this over and over until the brake rotor is brought up to 600 degrees Celsius, which makes it glow red hot. This is pushing the pads to the extreme limits. So extreme, chances are you'll never see this on the road. And we're gonna be doing this for both the galvanized and the painted pads, which will get them ready for the next test, the corrosion chamber test. So here's the painted brake pad and the galvanized brake pad after the dyno. The idea is to give them some wear and tear so we could test them in the corrosion chamber. This is the corrosion chamber, which uses salty, humid air to simulate about 2 months of winter driving. So the lab technician is going to put both the galvanized pad and the painted pad in the corrosion chamber so we could see the difference. So with the lid closed, the salty, humid air is being circulated, and we have to wait about a day for the test to complete. And a day later, we are ready to see the results. So let's remove the pads from the corrosion chamber and check this out. Right away, you can see the painted pad has rust on it, and the paint is peeling off the backing plate. And remember, this is after a simulated 2 months on a winter road. And then with the galvanized pad, the zinc does its job. It provides a sacrificial layer and protects the steel and prevents it from rusting. So it's pretty cool to see how the galvanization prevents the steel from rusting. Now let's take these 2 pads to the shear test machine. This right here is the shear test machine, and let me show you what it does. So this black metal piece is gonna push on the side of the brake pad and measure the force it takes to break that friction material off. Now we're gonna load the brake pad into the holder, add the top plate over the pad, and lower the top arm to hold it in place. Now the gauges on the right are reading the force it takes to break the brake pad material off. And the top is the mechanically attached pad, and the bottom is the glued pad. So let's start the test. Right now the force is increasing until the brake pad fails. Oh, and you can see the glue pad just failed, and the mechanically attached pad's still going. And there you go, finally it failed. So it took more than double the force to break it. So with the painted pad, the glued friction material popped right off, and with the galvanized pad, you can see the hooks held on to the friction material. And what's really cool, this is the brake pad that we made. And while it's awesome to see lab results, let's go out into the real world and test this out. And instead of driving some fancy sports car, this is gonna be my test vehicle. It's a Chevy Tahoe. It weighs over 5,000 pounds, a nice heavy vehicle, something that regular people drive, and it's really gonna put these brakes to the test. So let's go get these installed. So we're gonna install the galvanized brake pads in the front of this SUV, just like that. And then we could install the brake caliper and finally tighten down both bolts so they're snug and we're ready to go. Now we're gonna torture test the brakes by doing repetitive hard stops. So I need to floor it and then head down the track, wide open throttle, until I hear a beep, which means I hit 60 miles an hour. Now I'm hard on the brakes until we come to a complete stop, and I'll be doing this over and over and over. And finally, after 15 panic stops, the brake pads caught fire and the temperature of the brakes were just under 600 degrees Celsius, or about 1100 degrees Fahrenheit. So we really put these brakes to the test today, and we got to experience that firsthand. So there we go, how cool is this? We started out with a coil of pickled and oiled steel, then we stamped that to make a backing plate. We added a mechanical attachment using the NRS press, then we galvanized it to prevent rust, then we added our semi-metallic friction material, we added a shim to prevent brake noise, and finally we have our completed brake pad. And that's everything on how brake pads are made from start to finish. So now there's one more thing we need to do, and that is fly home to good old New Jersey and install our brand new brake pads. So out with the old rusty brake pads that are stuck in here, and look at how rusty these are. Then we can remove the caliper to give us access to remove the old rotor as well. Now in with the new rotor, torque down the caliper to spec, and now we're ready to install the brake pads. So let's get the new stainless steel hardware installed into the caliper, and these just snap into place and allow the brake pads to move freely along a smooth, clean surface. Good. Now we'll add some anti-seize onto the brake caliper pistons, and let's install the included piston cushions. And these are something new to the market, and they help prevent the brakes from making noise due to rubbing against the bare metal caliper pistons. You just need to push them into the piston, and that's all there is to it. Alright, so with our piston cushions in and our brake hardware in, there's one last thing we need to do, and that is install the brake pads that we made. I like to add a very thin coat of anti-seize to the back of the caliper and to the brake hardware, and this helps prevent brake noise and keeps the pads moving freely. Now we could add the pads, and it goes right into place just like that. And notice how easy these go in? That's why it's important brake pads are built to tight tolerances and OE spec. Then we could close up the caliper, and finally we could tighten down the caliper bolt, and we are done. So there we go, out with the old rusty seized up brake pads and in with the nice brand new ones. And the best part is we learned how they were made from start to finish. This was easily one of my most favorite videos to make ever. What an experience, and how cool is it to actually see how brake pads are made. It's one thing to install them in your car, it's another thing to learn what goes into making brake pads. Now, I do want to thank NRS Brakes for supporting the video and making this possible. You guys didn't see what went on behind the scenes, but they shut down part of their factory so I could go and film and show you guys each step of making brake pads. Not only that, we got to see things that not many people get to see. I got to get it on camera and share it with millions of people so we could learn how brake pads are made. And again, thank you very much. I'm gonna link their brake pads in the description so that if you guys need brake pads, you saw what goes into them, you saw the quality, you could find them down in the description. I think it's pretty cool to run brake pads that you actually know how they're made. Speaking of how it's made, this is my first time making a video like this. Normally I do how to replace brake pads or how to replace a wheel bearing, not how it's made. Let me know in the comments what you guys thought. Is this something that you want to see me continue doing? We could make a little series out of it. Hopefully other brands reach out and we could see how, I don't know, wheel bearings are made or tires are made. Comment some ideas down below if you like this. And as always, if you enjoyed the video, remember to give it a thumbs up. Also, if you're not a subscriber, consider hitting that subscribe button for more videos just like this. And finally, again, I'm gonna link this brand's brake pads in the description. Go check them out. I'll also link a video on how to replace brake pads from start to finish that goes in depth so you know exactly how to do it yourself.